Intervals and segments. An interval is a set of numbers in which all values are included except the bounds. It is expressed through the curved brackets. For example, if we see the following written somewhere, 3, 8, we read, the interval that includes all values between 3 and 8 without these two bounds. A segment, on the other hand, represents a set of numbers that besides the in-between values includes the two bounds as well. A segment is expressed through the square brackets. Thus, if we see written 4, 11, we read the segment that includes all values between 4 and 11 including the bounds. Intervals are shown in the number line by white, empty, dots, while segments by black, filled, dots. Look at the figure on screen. We say the ends of an interval are open, while those of a segment are closed. On the other hand, when the lower bound, the left end, is open and the upper bound, the right end, is closed, we have a half interval. Likewise, when the lower bound, the left end, is closed and the upper bound, the right end, is open, we have a half segment. As you see, the first, left, bound gives the name to the structure. Look at the figure on screen. Example 1. Express the number sets, -2, 7, 1, 4, 0, 5, and 1, 8, in the number line. Solution 1. -2, 7, represents a half interval. It is open at the left and closed at the right end. It is shown in the number line on screen. 1, 4, is a segment. It is closed at both sides and is shown in the number line as shown on screen. 0, 5, is an interval. It is open at both ends and is represented in the number line as shown on screen. 1/8 is half a segment, it is closed to the left and open at the right one, as shown on screen. When one end of a number set extends to infinity, we represent that part using the symbol of interval, as it is impossible to find the exact value of infinity. For example, the set that extends from 4 to infinity, including 4, is a half segment that is symbolically written as 4 plus infinity. When shown in the number line, the part that goes towards infinity is open, as shown in the figure on screen. The same thing occurs when the interval points toward negative infinity. In this case, the arrow points left. For example, if we see written -infinity, 6, we read the set of numbers extending from -infinity to 6, including the number 6, or simply the half interval from -infinity to 6. Example 2. Show the following number sets in the number line. A, -3, plus infinity. B, -infinity, 2. C, -infinity, plus infinity. Solution 2. A. We have a half segment that starts from -3 and extends on the right towards positive infinity. Hence, when this set is shown in the number line, we get the following as shown on screen. B. We have an interval that starts from negative infinity and extends to the right up to the number 2, without including this number. Hence, when this set is shown on the number line, we get the following as shown on screen. C. This set extends to infinity on both sides, so it is indicated by a double-sided arrow in the number line shown on screen. That is all for lesson 2.2.2. To continue this tutorial, please watch 2.2.3, the degree of polynomials. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.